morning, students. We are going to talk about integers in this screencast. Not a lot of information in this screencast. Hopefully you have read the sections in your textbook, and there will be some videos further along in this module. So we're going to start with just in general, what is an integer? We've covered this before, but we can always use a reminder. So one way to classify them is to say whole numbers. And their opposites. Or we can also list them, 0 being dead center. So I'm listing the whole numbers right now. That's a 3. And then they go the other direction. So these are the opposites of the whole numbers. And so on. All right, so in terms of representing integers, so when we're introducing, different numbers, different operations, everything, we like to have concrete models. So when we're representing integers and teaching students about integers, we once again use set models, just like we did for whole numbers. And we use a unitary model for set models, meaning we don't use base 10, and we don't really need to, because once students are able to figure out the rules of integers on their own, they can apply those to numbers that are large enough to make us want to use the base models. So we just use a unitary model, so one object is equal to 1. But now with integers, we need to have one object being equal to positive 1 and one object being equal to negative 1. And you're going to see a lot of different ways they represent them. And at first, when I was looking for videos and diagrams and such, I tried to keep them all standard, and then I realized once you start teaching, every textbook you pick up is going to be a little bit different. So usually we use colored chips. So I believe your textbook says red is negative, and blue is positive. Nope, they say black. You are going to see some videos and some diagrams where they use red and blue and also red and yellow. And then I think this is pretty clear, though I don't know if you can find these to purchase or not, but instead when we want to say a negative, we can kind of draw a chip and just put a negative sign in there, so that means negative 1. And if we want to do a positive, we can just put the positive. So that's equal to 1 itself. So when we want to represent a number such as negative 3, we could use, and I think I'll just use so I don't have to worry about colors, we can use 3 negative chips there. And so that would show negative 3. If I wanted to show positive 3, I'd need 3 positive chips. So one of the most important things, especially when you start using operations, addition, subtraction, multiplication, you need to be able to represent 0. And that seems pretty obvious at first. So if I want to represent 0, then I put absolutely nothing down, right? So I don't have any positive chips. I don't have any negative chips. But you find out pretty quickly with integers that that's kind of the whole point of integers, is that they have this great property to zero each other out, if you will. So one way that I can represent 0 is I can put one negative chip and one positive chip. And these pairs of one positive and one negative are always going to neutralize each other, some people like to say, and make each other 0. So then I can, of course, I could do this for the rest of the semester if I wanted to. I could make 0 in an infinite number of ways if I wanted to. So this right here is also equal to 0 because every positive has a negative. Every negative has a positive. They all neutralize each other, and essentially it's like having no chips at all. So we'll do one more example here, and hopefully you've read in other sources so that you know more about this. But if I wanted to do 3, pretty obviously I could do 3 positive chips. But I also could keep changing this representation if I wanted to. So to represent 3, I could also add another positive, but that's 4, but not if I throw a negative on. So this representation right here, this represents 3. Kind of in a strange way, but it does represent 3. I could do this again for the rest of the semester if I wanted to. Add another positive, add another negative. It doesn't really matter where I add them. I kind of have this little thing going. But as long as I'm thinking of this as a group together, so I've got these 2 negatives. They cancel out to the positives. I'm left with 3 positives. So I think you've got the gist there. So there's an infinite number of ways to represent using the set model. Now for measurement models, really we're talking about a number line here. And a lot of times teachers will use thermometers when first recording, like temperature for outdoor thermometers. They're going to be vertical, but it's the same thing. Because it's, one of the things, in real life that you actually have negative numbers. And they can see the positives are above 0 and the negatives are below 0. And so it becomes important to note that 3 and -3 have the same magnitude, but they're in a different direction. So they match up with each other, but one is below 0 and one is above 0. So what is the opposite of a number? The opposite of a number is the number of opposite sign, which maybe just sounds like I reworded this to make no sense at all. But if I kind of make a little chart here, so on this side I put the number, and on this side I put its opposite. So my number is 7, its opposite is -7. If my number is -2, its opposite is +2. So the point is we don't want to think of opposites as always being the negatives. The opposite is positive if you start with a negative number. All right, I have no idea why the font changed here, but we'll go with it. So my next question is this expression right here, I've got a negative sign in front of the letter A, positive or negative? And the question, where does it go on a number line? This is an important concept. I focus on this a lot. What we have to remember is A is a variable. And A is any real number. That's what we assume variables stand for unless somebody tells us otherwise. So any real number, any number I want, positive, negative, fraction, decimal, whole number, it doesn't really matter. So the point is, if A is any real number, then the opposite of A, well, it might be positive, or the opposite of A might be negative. So my answer is going to be depends on the value of A. So if, let's give just some real numeric examples. If A equals 7, then the opposite of A is negative, right? But let's say if A is -3, then the opposite of A, the opposite of -3 is the +3, is positive. So what that means is, on a number line, I don't know where A and the opposite of A go. And I don't think your book does a really good job of showing this, so that's why I wanted to bring it up again. I don't know if A is positive, then the opposite of A is down here, it's bookend in the negative territory at -A. That's possible. But I don't know that that's what it looks like, because what if A is negative to start? Then the opposite of A would be up here. So both of those number lines could be correct. I don't know which one is. Okay, let's see if we can finish getting through this here. So the symbol, all right, so students have to start using that symbol. And what can kind of be confusing when they're learning integers is that they've seen that symbol before. So that little dash up to this point means minus, or take away, of course. But now we also use it to say negative, and we also use it to say opposite of. Oh, that worked. All right, so let's just a little bit of practice here. So if I'm looking at this, I definitely don't want to say -8. I reserve the use of the word minus when I'm performing the subtraction operation, and I'm not subtracting that from anything. I reserve the word opposite of if I can't correctly say the word negative. I know this is -8. I want to convey to people this number is less than 0. I know it's less than 0. So I say -8. This one, I don't want to say -A, because then I'm implying that I have a negative number. But as we talked about up here, I don't know if this expression is positive or negative because nobody has told me what A stands for. A stands for any real number. So the best way to say this is opposite of A. Okay. Now the next one, yes, I know you're itching. Two negatives make a positive, right? But we want to read it aloud as written. So this would be opposite of the opposite. Opposite of the opposite. Of A. And if you read that and you think about it, that tells you exactly why two negatives undo each other. And it gets us back to A again. Again, we don't know if A is positive or negative. We just know that if we take the opposite and then we take the opposite again, we get back to where we started from. We get back to the original A. All right, this last one. So here's where I'm finally using the symbol to mean minus because I have a minuend and a subtrahend. So I'm doing a subtraction problem. So this is 8 minus the opposite of A. All right, guys, that is it. I hope you enjoy the rest of the module.